Hello students, I welcome you all once again on my YouTube channel. So in this video we are going to discuss we are going to understand the definition of group with the help of examples. Okay, so in last video we defined what is group, right? We defined what is a group. So as we saw, a set is called group if it satisfies four property. First was closure property. In closure property, A star B should belong to G. Second was associative property. In this, A star B star C should be equal to A star B, operating this first, which is written in the bracket. These should be equal for all A, B, C belonging to G. Then third property was existence of identity. In existence of identity, there should exist a element E. There should be an element from G such that A star E should be equal to A. And lastly, we did inverse, existence of inverse. Okay, for all A belonging to G, there shall exist an element B such that this should be also from G, such that A B should be equal to E in either way. Okay, so also if group satisfies one more property, which is known as commutative property, then the group was as we said, the group is called abelian group, right? So this was your commutative law. Commutative law was or you can say commutative property. A star B should be equal to B star A. So this was commutative property. Now one more thing I want to add here. If any set satisfies one property only, then this set is known as groupoid. A groupoid is a set which satisfies only closure property. Groupoid. Okay, if set satisfies two property, closure property and associative property, then this set is known as semi-group. This is not full group, but this is semi-group. Okay, because it is satisfying only two property, that is half of the four, so it is known as semi-group. A set satisfying three properties, closure law and associative law and existence of identity, is known as monoid group. Monoid, not group, but 3 property. This is known as monoid. That is, one property is less, or you say you need one more property to in order to get full group. Okay, if a set is satisfying all four properties, then this set is known as group. If one more property is satisfied by this set, then this set is known as abelian group, or this group is known as abelian group or commutative group. Okay, so now let us understand the definition of group with the help of examples. Okay, so example first. So set here would be natural numbers. We are going to check set here would be natural number, and operation would be star would be addition. Okay, we are going to check whether or not this natural number is a group under this addition operation. Okay, so fine, as let us take firstly, in order to prove this set a group, we need to satisfy 4 property: closure property, associative property, existence of identity, and existence of inverse. Okay, so first, property 1. First, property 1 is closure property, right? So closure property for this, in order to prove that this group is closed under addition, we are going to take 2 elements from natural number. Let a comma b belongs to natural number n. Okay, so as we know, addition of 2 natural number is natural number again, so we can say a plus b again belongs to natural number. Therefore, closure law or closure property holds n natural number under addition. Okay, now property number 2. Property number 2 is associative law, right? Okay, associative law for this, we are going to take 3 elements from natural numbers. Let us take a, comma B and C from natural number n. Okay, so we know A plus B plus C is always equal to A plus B plus C, A plus B plus C. Therefore, associative property holds in natural number under addition. Okay, now property number 3, existence of identity. There exist, yes, in order to find out identity, we are going to write this expression, or we are going to take A from natural number. So can you tell me any number which when added to this A yields A again? So this number is in 0, but 0 is not natural number. I mean to say 0 does not belong to n. Therefore, this is the violation of third property. Therefore, we can write natural number set of natural number doesn't have identity. Okay, there exists no number which when added to A we get A again for all. This is not true. Okay, because 0 was the identity, but 0 doesn't belong to natural number and therefore doesn't have identity. So property 3 is not satisfied. Thus we can say n is not group, right? But it is semi group. It is not a group, but we can say this is this set is semi group under addition. This is very important, last line, under addition, because it may be group, may not be group under in multiplication, division and subtraction. Okay, so right now we discussed this natural number under addition. Now let us discuss natural number under subtraction. Okay, so let me write it here. Example 2. Here the set will be again natural number and operation will be subtraction. Now let us see what is the behavior of this natural number under this operation. Okay, so firstly we are going to see does the set satisfy closure property or not. Okay, property number 1, which is closure property, CP I'm going to write for this, but you need to write it fully. So for closure property, let us take two elements from natural number n. As we know from the basic mathematics, a minus b may be natural, may not be natural. It is not natural always. So we are going to say one second, it is not natural always. Okay, so first property has been violated. One second. For example, you can see 10 is natural number and 20 is also natural number, but 10 minus 20 is equal to minus 20. This is not natural. For example, 10 minus 20 is equal to minus 20, which is not natural. So therefore we can say this set is not a group under subtraction. Also, you see, if we want to check second property, that is associative property, it doesn't satisfy associative property, even it doesn't satisfy associative property, right? Property number 2 is associative property. So if you take three natural number like this, 1 minus 2 minus 3, so this will be yielding minus 1. So minus 1 minus 1, this is minus 4. But if you see 1 minus 2 minus 3, it is equal to, this is minus 1 minus minus 1, which would be equal to 2. Okay, so therefore this associative property is not being held by this set. Therefore we will say this natural number is not a group under addition. It is not even group wide under subtraction. Sorry, I said addition in last sentence. So we concluded this is not a group, not even group wide. In next example, we are going to take whole number. Example 3, and this we are going to take whole number. Whole number is a set of natural number plus 1. ओके, अप टू सो ऑन, 0 से लेकर infinity तक. And operation will be addition here. Operation would be let us take operation addition here. So I want you to check whether or not this would be a group. First, property number 1, you see addition of two whole number is whole number again, so property number 1 is satisfied. Second, again associative law, for addition whole number follows this associative law. Second property is also held. Third, existence of identity, 0 is there, yes, this is a this set satisfies third property also. Now, but there would be no inverse in this case. Okay, I want you to check this out, and okay, let me write it here only. For property number 1, which is closure property, let a comma b belongs to whole number, then we know from elementary basic mathematics that a plus b is also whole again, because you know, if you are taking two whole numbers and you add them, you are again going to get either 0 plus 0 or anything which would be again whole number again. Okay, so therefore first property is followed by this set. Therefore closure property is followed by this set under addition. Now property number 2 again. Property 2 will be also satisfied. I want you to write it on your notebook. Property 3 since there exists 0 belonging to whole number such that a plus 0 is equal to a is equal to 0 plus a in either way. Okay, this is true for all a's belonging to W. Okay, therefore we can say this 0 is the identity. Okay, this is identity, therefore identity exists. Identity exists. Now property number 4. Existence of inverse. See, let roughly and rough you can write, we know 2 is a whole number, right? And can you tell me another number which when added to this 2 we get 0, right? So this number is minus 2, but minus 2 does not belong to whole number, right? So therefore we can say inverse of 2 does not exist in whole number. Thus property number 4 is violated, and this group is this set is not a group. In fact it is monoid, right? So let me write here. Now you can give this example, right? Since inverse of A belonging to W is minus A, but W contains only positive non-negative numbers. Therefore inverse does not exist in this case. Hence it is not a group, and we can say, but it is monoid. Okay, fine. So these are some examples of these are some we are trying to understand the definition of the group. So I hope you have understood the definition of group.